Welcome back to sqadia.com. My name is Osama and we are talking about statistical tests in medical statistics, and this specific lecture is about tests for correlation, in which we're going to talk about both Pearson product moment correlation as well as Spearman's rank order correlation, and we're also going to talk about the interpretation of Pearson and Spearman correlation. So visiting once back to the parametric versus non-parametric test table, as we were doing in all of the sections of this lecture. So we are talking about the correlation here. So once again, we have two tests for correlation. One is the parametric test when we have the normally distributed data, and one is the non-parametric test, which is when we do not have the normally distributed data or when the assumptions of the Pearson correlation is not met. So for the normally distributed data, we have Pearson's correlation, and for non-parametric test, we have the Spearman's rank correlation to quantify linear relationships between two variables. So Pearson's product moment correlation, what is it? The Pearson's product moment correlation coefficient, also known as Pearson's correlation for short, is a measure of the strength and direction of association that exists between two variables, measured on at least an interval scale. And this test gives us the finding and interpretation based on which we can say if two things are directly proportional or inversely proportional to each other, or if they are not directly correlated to each other or whatsoever. Now, look at this picture here. So they are saying it's a non-linear pattern with outliers. Now, if you look at this graph, the linear pattern would be a straight line like this or like this. Now, but for some reason, I'm very happy with the data because it looks like this. Now, so this is not linear because it's like this. So first of all, it's not linear. And here we can see that there are two outliers as well. So what is the importance of this picture? What is the importance of this graph, that how the data is represented? It should be linear or not, because it relates to the assumptions of the Pearson's product moment correlation. And here this is. So one of the assumptions for the Pearson's correlation is that the data should be linear. But if we look at this picture, so data was not linear. So it means Pearson's correlation could not be applied on this graph. So linear is an assumption for Pearson's correlation. So assumption number one, that two variables should be measured at the interval or ratio scale, which means they should be continuous. Assumption number two, there's a linear relationship between your variables, as you can see here, in a straight line. And if it is not non-linear, then we need to visit the non-parametric equivalent of the Pearson's correlation, which was Spearman correlation. So to check whether a linear relationship exists between the two variables, we can create a scatter plot using SPSS, and this is known as a scatter plot. So this is linear, this is non-linear, and this is once again non-linear. So if the relationship is non-linear, we cannot use the parametric or the Pearson correlation. We should go for the Spearman correlation. So if the relationship in your scatter plot is not linear, either run a non-parametric equivalent to Pearson correlation or transform your data to make it normal and linear. Okay, now assumption number three is that there should be no significant outliers. And if you remember this picture, which is the meme here, so there were two outliers here as well. So once again, this was not fulfilling the assumption for the Pearson's product moment correlation. But the third assumption is that there should be no significant outliers, and outliers are simply single data points within your data that do not follow the usual pattern, and they can affect the interpretation of the results. How? Just take a look at this example. Here we have a linear relationship between two variables, and we find out the Pearson correlation, for which the Pearson correlation was found to be 0.4. But here we can see that we have this one outlier here as well. If we exclude or remove this outlier, then the Pearson correlation coefficient becomes 0.7 just by removing this one value, which means that an outlier can significantly and drastically change the result and interpretation of the results. So that is an assumption for Pearson correlation, and always take care of the outliers before applying Pearson's correlation. So for example, how it is an outlier? Here's an example that in a study of 100 students, IQ scores where the mean score was 108 with only a small variation between the students. But one student had a score of 156, which was very much away from the normal distribution of the data. So that individual was an outlier, and we need to remove or exclude that individual. Now, assumption number 4, your variable should be approximately normally distributed. As you already mentioned, for all parametric tests, that is an assumption which needs to be fulfilled. Now, how to apply Pearson's correlation? So go to correlate, click on bivariate, and put all the variables for which you want to determine the correlation. Click on Pearson's, and you will get this. So here you have 0.706, which is the Pearson correlation coefficient. If it is related to 1, which means that there is a strong association. And if it is in plus, here it is in plus, so it means there is a positive association. If one is increasing, the other is also increasing. If it was in minus, then it would mean that there's a negative association. Moreover, if you look at the significance, which is the p-value, it is less than 0.05, which means it is height and jump distance are strongly and significantly positively correlated with each other. That's how you would interpret it. Now moving on, if we have non-parametric data, and if the relationship between the data is not linear, and if the data does not fulfill the assumptions for Pearson correlation, then you can go for Spearman's rank order correlation, or just Spearman's correlation. So Spearman's rank order correlation coefficient, or Spearman's correlation for short, is a non-parametric measure of the strength and direction of association that exists between two variables made on at least an ordinal scale. It is denoted by a simple RS, or the Greek letter rho. This is actually pronounced as rho. So this test is used for either ordinal variables or for continuous data that has failed the assumptions necessary for conducting the Pearson's product moment correlation. But if the assumptions are met, always go for the Pearson's product moment correlation. Now, what are the assumptions for Spearman's rank order correlation? Number 1, the two variables should be made on an ordinal interval or ratio scale, which means ordinal or continuous. And assumption number 2 is there is a monotonic relationship between the two variables, which means if one is increasing, the other is also increasing, and if one is decreasing, the other is also decreasing. That sort of relationship. So a monotonic relationship exists when either the variables increase in value together, or as one variable increases, the other value decreases, not that it changes with time. I'll give you an example. To find out the monotonic relationship, you can create a scatter plot using SPSS, and that can tell you if this is monotonic. So this is linear and monotonic, this is non-linear and monotonic, but this here is non-monotonic. So we can use Pearson correlation for this, we can use Spearman correlation for this as well as this, but not this. So that is one thing that you have to keep in mind. Always create a scatter plot before deciding which test of correlation to use. How to apply Spearman's correlation? Go to correlate, click on bivariate, put the variables that you want to analyze, and click on Spearman instead of Pearson's, and here you have that. So correlation coefficient, you have 0.669, it means it's in the positive, so it means that there's a positive association, that English and maths marks are positively correlated with each other, and p-value less than 0.05, so positively and significantly correlated with each other. So that would be the interpretation of the Spearman's rank order correlation in this example. So that was all about the non-parametric tests of significance and parametric tests of significance in terms of finding the correlation between variables, in which we talk about Pearson and Spearman correlation. I hope you learned something new out of it. Thank you very much for watching sqadia.com. This is Osama signing off.